y equals negative 2x plus 2 over x squared minus 9. First, simplify. That's negative, well, doesn't really matter, 2 negative x plus 1 over x minus 3, x plus 3. There again is difference of two squares. Okay, nothing I can easily cancel out. You might have preferred to go minus 2 out the front, then you have x minus 1 on the top. Doesn't really matter. Okay, ideas. Intercepts. For the y-intercept, set x equal to 0. Y equals 0 plus 2 over 0 minus 9. It's negative 2/9. For the x-intercept, set y equal to 0. So my function equals 0. Means the thing on the top of the fraction is going to be 0, doesn't it? 2 negative x plus 1 over x minus 3, x plus 3, but I don't actually care about the bottom. Only the top can be equal to 0. 0 equals 2 negative x plus 1. Well, this can't be 0, so this is only 0 when x must equal negative 1. Nearly got that wrong. No, positive 1. X minus 1. So that's my x-intercept. Discontinuities. Where is my graph not defined? Well, it's not defined whenever x squared is equal to 9, which means x is plus or minus 3. Discontinuous, where x minus 3, x plus 3 equals 0, i.e. x is 3 or negative 3. So I'm going to have two vertical asymptotes. Two vertical asymptotes. Okay, extremities. Well, we just learned a rule about the extremities. It's going to tend towards 0. As x approaches plus or minus infinity, y is going to approach, let's look at it in this case, minus 2 on x, which is going to approach 0. It is interesting it's minus 2 on x. Okay, it's a over cx. This is actually going to tell me the sign. So, if x is large but negative, y is going to be above 0. If x is large but positive, y is going to be below 0. So I've already got some idea what's happening around that asymptote. Now, there is something else we need to think about for the asymptote. Does the function cross the asymptote anywhere? Well, let's find out. To find that out, I need to work out whether this function is ever equal to 0, value of my asymptote. Does graph cross y equals 0, my asymptote? Set 0 equal to my function. Wait a minute, I've already done this. 0 equals my function was in fact my x-intercept. So the answer is yes at 0, no, y coordinate is 0, at 1, 0, at my y-intercept. I already answered that question. Okay, I think I know enough to have a go at sketching it. What do I know? I know that the y-intercept is minus 2/9 and the x-intercept is 1. X-intercept is 1, 1, 0, and the y-intercept is just below 0 minus 2 on 9. That's that point there. I have asymptotes, vertical asymptotes at x equals 3 and x equals negative 3. I have a y, I didn't actually mark it. This is a horizontal asymptote. I didn't actually mark it on my solution. Okay, y equals 0. It's going to be a pain to draw. Don't know very much yet, do I? So I want to find out what's happening to the graph at each side. I decided that as x was negative at the extreme, y was positive, and as y was positive at the extreme, as x was positive at the extreme, y was negative. So I'm here, and I'm here. It doesn't cross y equals 0 anywhere else because I checked for that, so it must be going up to here and down to here. Now what happens in the middle? Well, it only crosses at one point here, so it's got to be up here and down there. So sometimes I can get away with not substituting certain values. What I don't know is how close it comes here or here. So let's try substituting x equals negative 5 and x equals positive 5 to get an idea of where that curve goes. Because the one in the middle is going to come up through there and up. I might even draw that straight away. It's going to come up through there and up. It's the only way to make that happen. What's the shape here going to look like? Let's substitute some values in. If x is negative 5, then y is minus 2 times minus 5 plus 2 over 5 squared minus 9. That's 10 plus 2 is 12. Over 25 take 9, which is 16. Which is 3/4. That's actually quite low. When x is positive 5, y is going to be minus 2 times 5 plus 2 over the same 5 squared minus 9. So that's going to be negative 10 plus 2 is negative 8 over the same 16. Which is going to be minus a half. All right, now put those points on my graph. Negative 5, 3/4. That's actually very low, isn't it? Negative 5, 3/4. This one is 5, negative a half. Okay. Now join those up. It's going to be quite a sharp hyperbola. Sorry, the name of this kind of curve is called a hyperbola. Oops, not supposed to go back on itself, but it's quite sharp. It's going to go out to there. And there is the graph of my function, y equals negative 2x plus 2 over x squared minus 9.